Hello everyone. So today we are going to learn introduction of our ladder diagram software, that is Siemens PLC software, that is TIA, totally integrated automation software. We are using version is V18. Here in this we are going to learn about the introduction of the software. We'll start with it. So we have multiple softwares. We have PLC Assistant, we have PLC Sim, we have WinCC, we have advanced softwares. So those are all supporting softwares, but the main software is TIA Portal V18, that is totally integrated automation portal V18. So we are going to double click on it and open the software. It takes some time to load the software. Yes, so the opening screen you can see towards your left is open new project, create new project, or open existing project. So we are going to click on create new project, and you can give any name to it or anything. And the file where you want to save it, you have to give that file name as well, or the folder where you want to save it. So you can check it is V18, the version 18 software, and say create. So it is creating a new project. So now you can see we have got a new window, say open existing project, new project, migrate project, and to the left hand side we can say start, device network, PLC programming, motion and technology, visualization, online and diagnostics. Towards our right side we can see configure a device, write PLC program, configure technology objects, and configure HMI. So we are going to click and say add a new device. So whatever the steps were there, those are all the steps. So first you have to configure a PLC, then write PLC diagram, then diagnose, and then check. So that is how we are going to follow. So add a new device, controllers. So you have to click on controllers. We have HMI, we have PC system. So click on controllers. In controllers we have various series for our PLC. So we have 1512C series. In that we have this CPU 1512C1PN, and you can see it has a unique article number, and you can see there are functions. So click on add. It will give you all the description showing how many DIDOs are there, how many analog input outputs are there, what all are its memories and all, clock functions, everything will be shown here. Digital output, how many are there, all the things. So you can read it in the description and say add. Here we have got a new window. So uncheck on the PLC configuration. So we don't want to protect our PLC with any kind of password. So we have to put that, and always check this. Always the PC and this PLC should be turned on. The security between the PG and PC and HMI and the PLC should be turned on. You should always allow and say give full access. Click on next and say give full access, no protection. Say next. Here you can see we have disabled our security, we have enabled the PG PC communication, and we have given full access. Say click OK. We can finish it. And now we can see here our PLC has come here. You can see here. So our PLC has got configured. So we can check in properties, click on the properties below, see in the general, we can check all its input, what all in what channel, what input is there, what are its values. We can scroll and check. You can see our input address starts from 0 and end address is 9, that is previously set. So we have IO addresses, in that we can check. Now go to, in the left side, go to program blocks, main OB1. So here this is the main window where we do PLC ladder diagrams. Towards our right hand side we can see instructions. In those instructions we have many instructions where that are NO contact, NC contact, normally open, normally close contact. We have bit logic operations, we have save project, we have undo, we have compile, we have to download it to the device. All the options will get enabled once we start programming. We have start simulation, we have run time, go online, offline. Those are all the options on the upper hand side. And here to our right hand we have, in general, we have open branch, close branch, we have bit logic operations like NO contact, NC contact. So you can just drag and drop, or you can click and drag it to the green point. Wherever the green point comes, it gets connected there. The closed bracket is nothing but our output, and the open ones which we are seeing with the parallel two lines, those are NO and NC contact. So if you can click, keep your mouse there and click on the yellow pop-up, and you can see what is it. So it is like a helpline. See, here it is normally open contact. You can see what is its operand input, what is its data type. It is a Boolean data type, what are its memory, how it can be used, where it can be used, how do we have to use it. All the things you can self-learn from here. See, normally open contact depends on the signal state of the associate operand. Close the window. Now here we have to give it as an input address. So say I is our input address. We have to always give I whenever we are giving our input. Say I 0.0 is my initial input. I 0. So you have to always remember, if you give the dot before or after, it will give wrong. It will give it will give red. So it should not come red. The syntax error should not be there. So it is I 0.0, 0.1 and so on. And followed by I is our input. So Q is our output. So any address will be used in the input will be used with I, any address used with the output, it will be used with Q. And now we are going to give the tag names. So there it is given tag 1, tag 2. So we can't understand, so we have to rename it and give it as A and B. Here we are doing our AND function, okay, for understanding how it is done. So output I have given as output. You can consider it as Y or output. A is my first input, B is my second input, and Q is my output. Say AND gate. Here in the networks also you can write which program you have done, so that later when it is a lengthier program we can diagnose it. So here we can give multiple networks. We have other options like timers, counters, comparators, and all the things.